Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Let's start off with the Baca Surah Al-Fatihah. Okay. Yeah. Okay. So today we'll discuss on this one, Introduction to Internet of Things. Okay, so this is taken from the Precision Timothy Chu. He was the what you call uh, the the one that is in the company. So has industrial experience. So he has the industrial experience. So I found that this one is the easiest one. You can you can find many frameworks, okay, but I found that this one is easier. Okay, so whenever you have problems, divide and conquer, you select one by one. Okay. So yeah, so these precisions, we will discuss first on the IoT framework. Then after that, we go to the examples one by one. Okay. We go for like precision mining, and then we go for other things. Okay. Okay, so let's see the IoT frameworks. So first, we have things. Okay. So the first one is things here. So things can be sensors, computer architecture, software, security, packaging. Okay. As I mentioned earlier, that in industrial setting, you need to pay special attention not only on the working, is it working or not. For example, if you cannot directly put Arduino into the industrial settings, okay, because you need to have proper packagings and so on. Okay, otherwise, when there's some vibrations, then it fails. Okay, so you need to have not only the software, hardware, and also the packaging in one day. And for industrial sensors, as I mentioned earlier, industrial sensor need special treatment because maybe the working environment is very harsh environment and there are many noises. Okay, so you need to filter out all the noises, and at the same time, it needs to be accurate. Okay, so inaccuracies will make the product fail. For example, you are baking the cake, the temperature should mention 125 degree. You go below or you go after, the cake will fail. Okay, so it need to be precise. So that's why the term here, when we go IoT, precisions. Okay, so the precision. Then after we select the things here, then we go to the connect. Okay, so we go to the connect. Yeah. So the connect is the selection of communication technologies. There are many, okay, based on amount of data, not our importance. Okay, not our, for example, it could be overkill. You just want to transmit temperatures every 10 minutes, for example, but we are using 5G. You pay monthly, payment will be expensive. Maybe you just need some simple communication technology. So how far it needs to go, and also it depends on how far it needs to go. Okay, you can depends if you don't have the coverage, maybe you need to go to the Starlink, Elon Musk. Okay, that will be more expensive. But if requires, for example, you have the pipe for Petronas, for example, they don't have 5G coverage. Like it or not, they need to pay for the Starlink. Okay, because they want to measure. Otherwise, it's also expensive to send human to check the pipe for 1,000 kilometers. Okay, and then how much power you have? This is also important. The IoT normally you don't have much power. Okay, unless if you put some renewable energy, you put a wind farm or solar farm. Okay, then you can power the IoT device. Okay, so the connect we'll discuss more, and we'll see later on the examples. The things also we'll see on the example. Okay, and then the next one is the collect. Yeah, so the collect is a database. Okay, or you can say this is like a big data. Okay, because why? We have at least two things that we want to measure: something nomic and machine nomic. That's the data. Okay, something nomic. For example, if you go to healthcare nomic, the data for the healthcare. If you go to farming nomic, okay, agriculture, nomic, and so on, race car nomic. So you have the performance and you have also the machine itself. The machine can generate many things. And this one is fairly large. Okay? This one is very big data that you can have. Okay? And normally we put in time series database, in time series. Why? Because we have date and time and the value. Okay? We simply have date, time, and the value with the temperatures, pressures, and so on. Okay. Okay, and the next one we have learn. Okay, after we have the data, we found the knowledge base. Okay, we what you call label the data. Okay, we annotate the data. Okay, even the ChatGPT need to have annotated answers. You have the question, ChatGPT get the answer, and someone need to verify whether the answer is correct or not. Okay. Okay, then you have here learn. Well, yeah, learn here. So you have machine learning or deep learning algorithm. So normally you have three types: regression, classification, anomaly detection. Okay, regressions means you are trying to predict continuous value, okay, between 0 and 1, for example. Okay, so for example, if you have temperature like this, and your output will be a 1, okay. And classification is yeah, classification, we have so many classes, then you determine class A, class B, class C, and so on. Okay, so this is classification. Anomaly detection, normally what you do, so this is used for the machine learning. For example, you just record what is the normal conditions. And when there's some anomaly, then you can detect this is anomaly. Okay, suddenly there's some big amplitude. Okay, so that if you don't, what you call, you can detect, you train with the normal so that you can detect if there is some anomaly. Okay. And how to train? You have supervised, unsupervised, and reinforcement learning. Supervised means you give the labels, the data. This is orange, this is apple, this orange, apple. So you know that one. Unsupervised means you notice that it is object number one, but you don't know this orange. Okay, object number one, object number two, object number three. Okay. Reinforcement learning is you give reward, carrot, and stick. Okay. Learning you give reward and stick. If it is correct, you give reward. If it is wrong, you get punishment. So that later on, the algorithm will learn that you need to go to that way. Okay. So for example, reinforcement learning, how to go out to from the class. You can go this way, I give negative. Then you go this way, I give positive. Go this way, negative, because it's far from that. Okay, I go to that way, positive. Then the next one, I know that I need to go to that one. Then you go here. So this is reinforcement learning. Okay. Then the last one is the benefit that we can have. Okay, so the last one is the benefit that we can have. For example, improve quality of service. Okay, so yeah, of course, if you sell the service, then it improve quality because you know exactly what happens. Okay, so you know exactly what happens. So for example, later on in precision cut care, you measure the nurse measure the vital signs every 3 to 4 hours. Now they can have it every 10 minutes. So if there is some heart attack, it can be detected. Okay, can be detected right away. Can detect code blue. They said it's code blue. Okay, reduce cost of service. Okay, how we can reduce cost of service? You can see this is, for example, the simple example is machine learning here. How do you change your motorcycle oil, or how do you change your car oil? Normally, you the workshop put it every 5,000 kilometers. Okay, so if you, but this is the approximate. You don't know if you are heavy driving or you have less driving. Still 5,000 kilometers. Okay, so that's why if you measure the oil, sorry, if you measure the oils, the oil conditions, then we'll know maybe it need to change early, maybe you need to change later, 6,200, okay, based on the condition of the oil. So you have a oceanomic and then you can detect. So this one reduce cost of service. And also in the case of what you call in the case of precision healthcare, also reduce cost of service. Okay, because you need to pay the nurse every 3 to 4 hours. and it is cheaper to put the machine and then detect and send the vital sign every 10 minutes. Okay. Okay, then we have here a new business models. So the company now, this is called precision service. Okay. The companies now they sell the whole package, not only the machines, okay, but the whole package from the things, connect, collect, learn, and do. Okay, so you have what you call the new business model, which is precision service. Okay, lower consumable cost. This is similar like this one, the oil, just the oil. High quality of product or service because you have precise. Okay, so you have precision farming, so it precisely needs if this area need fertilizer or need water, precisely it will give the fertilizer. How? They measure the whether the soil is fertile or not. Okay. The last one, improve health and safety. Okay, this is also because you are based here. Yeah, we go later on profession mining. Even the disruption, it costs 15,000 US dollar per hour. Okay, so let's move on. So I hope you can memorize this one. This one will come out in final exam. Okay, so things, connect, collect, learn, and do. Okay. Okay. And let's see the industry example here. Okay, there are many industry has done here. Okay, you can also I put here one by one with the URL so you can what you call you can check for yourself. The things there are many things beside the Arduino. You have here the National Instruments, Illumina. I don't know what is that also. What's it called? The general electrics. EDCO. Yeah, EDCO is the one that we will discuss. So this is for precision agriculture. And connect, of course, you have Cisco, Vodafone, Huawei. Okay. For collect is database, so you have here many data. Okay, many database. The company normally use the Oracle. Okay. SAP, SAP, okay, Hortonworks, Teradata. Okay, learn. You have MATLAB, PyTorch. Oh, there's no PyTorch here. Yeah, I created this in 2018. Okay, so I should add some PyTorch. So at that time, PyTorch became popular. Okay, then you have here the do. Remember the business as service. The boss, Automaton, GE, IBM, and other things. Okay, so these are the examples. Now let's see one by one here the things. Oh, this is the IoT. Okay, so this is the IoT. As you can see here, this is a number of connected device in billions. In 2025, it will be more. More. This is industrial and this is the consumer. Just see how many handphone that you have now. Maybe at least two. Okay. Or you have two SIM card also. And this is what populations compared to the IoT. This is connected device. Ericsson connected device by predicted by IHS. So this is predicted by IHS by Ericsson. And this is the world populations. Okay, so you can see the devices are more than the human population. Okay, so now we have a smart car, we have a smart speaker. Okay, you can talk with your speaker, you can talk with the iPhone. Okay, and the what you call there are many things here, many sectors, industry, consumer, transportation, smart city, and other things. Okay, now let's see the things here. What are the things? You can see from here, as I mentioned, sensors. What I put here is the SBC. Okay, you can go to this one. Okay, and this is the SBC, and this is 2018. It might not. It might need to be updated also. Okay, and in terms of processor, remember that we have Intel, we have AMD, and we have the ARM. Okay, this is a RISC, and Apple put M1, M2. Okay, but we have the new one, which is RISC-V. Okay, and this is open source. Okay, this is open source. Okay, so RISC-V. So imagine that if Malaysia is being what you call by US or so blocked by US, we cannot buy Intel AMD, but we can still develop this one. Okay. So now we have the SBC using RISC-V architecture. Other things here you have, of course, NVIDIA Jetson Nano. Okay. uh, Google Chrome is good for AI inferencing. It's good for inferencing. Okay, not good for training, but it's good for inferencing. Inferencing, after training, you do the testing. Testing is inferencing. You give the new problems, then it will detect quickly. Okay, so this is faster using this one I have here. Sorry. I need to go to the, yeah, hopefully there's no more message on my Telegram. Okay, then we have here Asus Tinkerboards. Okay, so this is the things. Okay, but what we have left here is what? Sensors, software. Okay, so that's also the things. Okay, so even the iPhone, this is what, iPhone 14, okay, has various sensors. You have various sensors. You have the camera. Okay, you have the camera. This is what? This is fingerprint sensor. I'm not sure what is this. Maybe it's the antenna. So this also the antenna, but you have here various things. Okay, this is ultra wideband chip. Yeah, this is the sensor that you have, okay, in your phone. Okay, Face ID, lidar scanner, barometer, axis gyrometer, accelerometer, proximity sensor, impedance sensor. So you can see if you want to have, you can start with the IoT project using your handphone. Okay, your handphone, for example, can measure. It has been used actually. If you are using Google Maps, the data is sent back to the Google, so that the other person will be benefit. If there is some jam, so it will tell the Google server that there is jam in this Jalan Tun Razak. Okay, so that you'll see it will be red. Okay. Okay, so these are the examples. There are many. Okay, so this is just the hardware part, and some also has the complete package, not only hardware, operating system, the software, and also the sensors. Okay, but you have also the industrial sensor. You can connect to this one. Okay, so you can see here, Raspberry Pi. You don't need to memorize this. Okay, but whenever you work and there's a problem, there's some option here. Okay, of course you need to do the work there. Remember that we have what I instill now is PO1, engineering knowledge. After that, you need to do problem analysis. After that, you need to do engineering design, and then investigation, then modern tools. Okay, so that's PO1 to PO5. Okay. And yeah, so do you know Google Coral, ESP32? I think it's one so popular when you do IoT and FIP, Jetson Nano, SenseCap. I never know this, but you can see bigger one. I heard this one, particle IoT device, ICOM, STM32. Okay, so there are many things, okay, things that you can use. But remember that this is still hardware. Okay, now let's see the software. On the software part, you have here the free RTOS, free real-time OS. Okay, and you have Riot. And in Malaysia, I think we have pay for Riot. You go to here. Okay, they put not only device but also the software. Okay, you have Quantiki design. So if you are taking the OS, I will not discuss this one because it's special. Okay, Ubuntu Core, Mbed OS. So I've used this one. I've used real-time OS. The rest I haven't used. IoT's Quantiki Zephyr, Ubuntu Core. Okay, so it's specially designed for small device. Okay, because small device has limited power. Okay, and then for the software part, you have here Node-RED. This one can automate, can make your life easier. Okay, but of course, if you use this one for commercial, then you need to pay. Okay. So you have here Home Assistant, Arduino software, Platform IO, no, this is Amazon, and this is Azure, this is from Microsoft. Okay. Okay, so let's move on to connect now. Okay, connect means the technology to connect the IoT device to the internet because there is the term Internet of Things. And remember that this is IoT is the key enablers of IR 4.0. Okay. So the connects is a selection of technologies depends on the amount of data, how far it needs to go, and how much power that needs. It always depends on this one. Okay. So for example, you don't want to have if you on battery, you don't want to have a long range transmission because you need what you call power. Okay, your battery will die. Okay, so that you cannot measure the other thing unless if you're connected to power line, then you'll be okay. Like when you are doing in the chicken farm, okay, you all connected using the power line. So you can have what you call you can have unlimited power connected to the power line. Okay, so you can see here depends on the oops, depends on on the throughput, how much data that you need to send, and how much the range. Okay, so you can select here Bluetooth, Wi-Fi, LTE, LTE-M. This is for machines, specifically narrowband IoT, LoRa, Sigfox. Okay, and you can see here this is unlicensed spectrum. This is licensed spectrum. Unlicensed spectrum we have here on ISM, industrial, scientific, and medical. Okay, so you have three. Remember, the spectrum is expensive. If you buy the channels in the FM radio, for example, it may cost you 3 million ringgit to buy that frequencies. Okay, so that's why they put here is on unlicensed spectrum. Bluetooth is in 2.4 gigahertz. Wi-Fi is on 2.4 and 5 gigahertz. It's unlicensed. It means that everyone can use this one. But if because this unlicensed means there also the possibility of interference, because no one's stopping you to use also the same frequencies. Okay, it happens also when you have multiple routers, you have interference. Okay, then you have LoRa also here on the, this is longer, less than 10 kilometers. Okay, and this one is around 20 kilobit per second. Okay, this one even 2 kilobit per second. So depends. Okay, so this is the other visualizations. So this is the other visualization. Okay, so you have GSM. So this is the range in here, and this is the data rate. Okay, so invert from this one. Okay, now let's see what we have here is the promise of 5G. Okay, so this is the promise of 5G. 1 millisecond latency. So latency is 1 millisecond. Okay, means that from the beginning, starting transmit and to receive, the handshake is less than 1 millisecond. Okay, then transmit the data. Okay, and you have 1,000 bandwidth per unit area. 1,000 bandwidth per unit area, up to 100 number of connected units, 10 improvement, 99% availability, 100% coverage, 20% reduction in network energy usage, and up to 10-year battery life for low power IoT device. So if you design for IoT, you can get up to 10-year battery life for low power IoT device. Okay, means that you put something on the, you are measuring like in the jungle of Sarawak, you want to measure the animals there. Okay, so you can be there for 10 years. Okay, but of course you need to have the coverage of 5G. Okay, okay, so you have here 10. I think you can see later in the slide. This is sensor to actuator real-time communication for industrial applications. So from the sensors, maybe a remote sensor, and then you have actuator to drive the machine, is within that 1 millisecond. Otherwise, it will be you will destroy the product. Okay. Then you have your driverless car navigations. Okay. Using 5G, it is possible. Why? Because you have the camera sent to the server, process, and then within that 1 millisecond, you can detect all the risk. Okay, because you have a fast communication. Yeah, other things, healthcare, and also drones. Okay, so this is an examples. Is the list is not complete, but this some of the examples. Is that you can try to load to see here one by one, see what you need. But again, how much data, how long, what's the range, and how much power that. Okay, so that you need to trade off between that. Okay, so you cannot simply say I want to use Bluetooth. Why? It's easier. No, maybe it's not suitable. Someone can hack also, for example. Okay, there's no security in Bluetooth. Okay, okay, so you can read this one later on. It's Sigfox, Z-Wave, Thread. This is new things. I never heard this one. 5G, Zigbee, Bluetooth low energy, Wi-Fi. You have heard. LTE-M. This is for machines. This is for machine, not advanced, not LTE-A. NB, and the last one is of course Starlink. Okay, but remember that I don't put the details, but you can see put here. If there is no coverage, like Petronas want to lay down the pipe, okay, sending the oil, okay, like it or not, they need to buy okay, to have 100% coverage. Okay, this is constellation of hundreds or thousands satellite in geostationary. Okay. So that's so again this depends how much money that you want. If the pipe is important to Petronas, or they will buy it. They will buy the connection. Okay, so let's move on. The next one is collect. Okay, so for collects, things are not people's. The sheer volume of data that things can generate is greater than that of internet of people application. So you can see from this, like it's not good. Okay, so things are not people's means that you can generate more data compared to the people. Okay? So let's say that you want to post something on the TikTok. How many you can post a day? But using the internet and IoT, you can generate every 1 millisecond, 1 second. So, okay. So you can have here the three types of database: SQL, structured query language. That is the most popular and the most particular relational database that you have. Okay. Yeah, so this one designed for marine data in relational database. Okay. So for example, MySQL, MariaDB, PostgreSQL, using the ACID properties. And you have no SQL, non-SQL, non-relationals. So some operations are faster in no SQL and other faster in relational database. Okay, so for example, in Cassandra, MongoDB, Express. Okay. The other thing you have the time series database. Okay, normally for the AIT we use this one. Okay. Can typically process millions of events per second. Okay, you have influx database, time scale database, open time scale database. Okay. So this is database. And the fundamental for this one, normally you put in time series. Okay, so you hit that and the time and this is the value. You can have multiple value here. Okay, you can have the multiple value. Okay, but this one is your time series, time and date. Okay. Later on in the one of the examples, we see also this one need to be synchronized. Okay? Because 1 o'clock in Malaysia is not the same like 1 o'clock in Makkah, for example. So 5 hours behind. Okay? So you need to synchronize between the different time zones. Okay, so this again the examples. Okay, MySQL we have mentioned earlier here, Express. So this is another one that found is that database, cockroach database. Okay, also what I said, and yeah, baby. Okay, so the rest is I discussed earlier. So this is the URL that you can get more details on the database. Okay, so this is on database. The next one is on the learn. Okay, remember on the learn, we have three types, regressions, classification, and anomaly detection. Okay, and how it learns, you have supervised learning, unsupervised learning, and then reinforcement learning. Okay, so this is, you can see here, this is the history or the development of deep learning. The neural network is the oldest one. Then after that, the modification of the neural network long-term memory. Then after that, we have CNN. Okay, it's a convolutional neural network. Okay, then you have your deep belief network, and you have deep stacking network. I'm not sure what I never use this one. Critical unit, and this is done. Generative adversaries network, and this is what we use in ChatGPT. Okay, ChatGPT using this one. Okay, the GAN tag. So it can produce something. It can produce fake image. Okay? So you have the person is not there, but it can generate something like the face. So that's why it's generative adversaries. Okay, so you have generate. Is this people or not? No, it's not people. And then we go back. Is people or not? No. And then until say yes, these people. Okay, but it is not actually. So you have two part of writing each other. That's why it's called adversaries. Okay. These are the examples. You have TensorFlows. Okay, you have PyTorch, Scikit-learn. I think you have seen this one. Cafe. Of course, also the big company also invest in the machine learning, Azure machine learning, and then Microsoft invest in ChatGPT. So they integrated in the big chat. Okay, Google Cloud and AI and machine learning. So this is also by Google, but we have also the commercial version. commercial version of the TensorFlow. And it's from Intel. Okay, this is Grass. The interface, easier interface to TensorFlow. And MATLAB. Okay, and as IU student, you can install MATLAB freely. Okay, now we have the license for MATLAB. Okay. TinyML is specifically for tiny microcontroller. I use this one, for example, for Arduino BLE 36, the Arduino. Okay. IBM Watson, okay. IBM also has Oracle, Amazon. Okay. So the big company also have this one. But the one that is popular now, previously TensorFlow, because it has from the beginning until the end production. And now for research, it will be Python. Okay. So you have Python. So any YOLO will be implemented in Python. Okay. We have seen this one earlier. So this is how the business benefit for either the producers and consumers. So it can benefit both way, the producers or consumer. Okay. Improve quality of service. So this is for consumers. Okay. Reduce cost of service. This is also for consumers. Okay. New business model. So this is for both actually, the producer and consumer. Okay. Production service. So you means that initial investment is very expensive. If you buy the tractor, if you buy machines, it is very expensive. So we have here production service. So you just rent to us. I give you the machine. I give you the everything, the connection, the taxis database, the learn, and then we have to do it. Okay. Lower possible cost for this one will be for the producer. Okay. And higher quality product service. So this is also consumer. Improve health and safety. This is for consumer. Okay. So at least six. This is the two. The benefit that you can have if we implement the IoT framework. Okay. Any question? This one we don't have example. Example. Any questions? So what are the IoT frameworks? Please, then connect, collect, learn, and do. Okay. So when I ask you in the final exam, try to solve this one, you got the to specify things. What are the things? So it's okay. So you are doing that's just from there's no right or wrong. So you can from your memory, okay, what do you use very powerful. Okay. And connect. Okay, connect. Then you can use Wi-Fi, Zigbee, Bluetooth, for example. Okay. Then collect downstream database. Okay. And then the learn you can use machine learning. This machine learning, use SVM, support vector processing, and so on. We'll see on the examples. Okay. And then do what are the benefits after you do this one? What are the benefits for the company that you want to solve? Okay, you want the problem to solve. Okay, so let's see, move on. I have 4 examples here. Precision mining, farming, healthcare, and rescue. Actually, in the books, there are many. In the book, there are many. They have a gene sequencer, they have agriculture, it's not farming, but agriculture. Um, uh, yeah, many things. But this one is at least you have something here with queries. You can also use it for your book. Okay, now let's see the background. Precision mining. Yeah, so the cost of producing energy and extracting minerals. So this is the book is 2016. So the context you need to know that this one is 2016. 2016 there is no 5G, but now you can. But principle is the same. Things connect, collect. Okay. So at that times, 6 billion ton of coal is mined annually. China, 4 billion is 1 ton. The rest is 1 billion. It's 6. So 1. So China mines the coal. But now China with the Ukraine, the Russian war, the Europe also support renewable energy because they don't want to buy biofuel. Okay, and then in 2016, I put the content. 40% of the world actually is generated by coal. Okay. Now let's see what we are focused here. Coal mining. Okay, so how they do? They have the like this. Okay, they have the long wall, piece by piece like this. Okay, to get the coal. Okay, so this is what they do for to mining the coal. Okay, so now the issue here is how to make sure that the wall here is not collapse. When you stop, 15,000 US per hour. If you stop one day, just multiply 24. Okay? So how can we use the sensors, the data? So we use here two data. Okay, we use here. So we use here two data, which is mining nomic. Okay, and we have also machine nomic. Okay, so you have the machine. Okay, you have the performance also. How much it produce. Okay, how much it produce? This is will be mining nomic. Machinomics means the health of the machine itself. Okay, the health of the machine itself. Or will there be any collapse here or not? Depending the whether it's collapse or not. So let's see. So this is the precision mining. Yeah, so long wall mining is highly productive underground coal mining technique, cost from 45 to 150 millions, depending on machine size and complexity. So you can see here, to mine this one, take this, mine this one, take this, but you don't want this one to collapse. You have to make sure that it doesn't collapse. Okay. So you go here deep down, and then the control is up here, and then there's the issue on what on connections. Okay. How do you connect this one? Because you can't this one will be two my vibration, so you can put the server here. Okay, very good. So crash the button. Okay, so you send it put in a safe place, and then you put the process the data, and after that you send back what you started. Okay, so this is the things. Okay, so this long wall. Okay, so you want to make sure that it's a control. You know what? You need to produce as much as you can. Okay, as optimal as possible. So this mining nomic, and the data on the machine is machine nomic. Okay, so let's move on. Okay, so let's see here. So the long system utilized 7,000 sensors. So you can see, you can imagine here what are the sensors. 7,000 per second. 7,000 points, data points. Why this? Okay, so then you have Shearer have 6 onboard motors, 12 hydraulic function, unitary gate, inertial navigation sensor, okay, color and infrared cameras, and radio control interface. Okay, they also use high accuracy incremental encoders to measure movement. High accuracy incremental encoders, so you need to measure if I am now 1 centimeter, 2 centimeters, go to the wall and get the code. Okay. So the serial takes time measurement of multitude of temperatures. So you need to measure temperatures, oil levels, because why? Because when you drill here, it will be very hot. So how to cool down? You don't use the oil, or the machine itself to measure the oil. Okay? And then you have vibrations, pressure, and the flows. Okay. And then what you can see here, this is the things also. Consolidated control units, we have 1.6 gigahertz Intel microprocessor. You can see, not always that you need to have the fancy or the latest processor. In industrial, as long as this works, then it's good. This has been tested, it's validated, so you can use this one. Only 2 GB of memory, and they use the Xbox. This is the IOS. Okay. So for measurement, you want to have other type IOS. And the connects, I see the connect. So the mining equipment is connected to control on the surface. So you have here the mining and here the surface. How to connect this one? You use fiber optic and copper data cables. So you fiber optic here and copper data cables. Okay. Copper the network switch, routers, and others commercial hardware. Uh, proprietary wireless system compatible. So you can see proprietary wireless system means that it has some modified protocols. Okay, so that you cannot you go to the local many and connect to Wi-Fi. Okay, so this one is specially designed for the machine. Okay, why is that? You just remember this one. I can put it in. Okay, so this is the long wall. The machine is in here. Maybe you put the Wi-Fi, send it to the router here. You can hit from here using fiber optic. Okay, so this one is only designed for close proximity, 60 meters. Okay, because hopefully this is safe. They will not fall down. The wall will not fall down. So you put the router here. If this is safe, then you put another router here. Okay, and you take the cable there. Okay. So for longer distance fiber optic and power line modem communication. So this is also power line communications. Are used so you can put the signals into the power line. Okay. So around 160 machines, 165 machines had been connected to computers on the mine surface. So you can see how efficient it is. So you can put 165 machines or connected to the mine surface using what the Wi-Fi for close proximity. This is not normal Wi-Fi, but proprietary Wi-Fi. And then after that, use the fiber optic go to the interface. Underground, just for this one only. This is line of sight. Can work if you don't have any. Yeah, the same thing like when you have here in the class, for example, it's only working in the class. Okay, so after that, you cannot receive the signal. Okay, so you put here the transmitter and this is the router. Okay, so short distance is okay, but long distance then you use fiber optic. So, okay, so data and then we see now the collect examples. The collected is in Aspen Tech. I don't know what this is. This is the commercial one. The time, but this is a time series database. Okay, data is collected once per second. It's kept for a year. Then archived. Okay. One of the challenges that the data collected in more than 100 different time zones from equipment or multiple. So it means that this is in China, this is in US, this is in Europe, for example, this is different time zones. So it need to be synchronized. Okay. Okay, so this is the mining. Of course, if you send the data, then the data center can be anywhere. Okay, no need to be in by the mining location. Can be put maybe on Iceland. Okay, it can be put anywhere. And the last, so the key technology here is shear atmospheric shearer and oil analysis and vibration analysis. Okay, the one that I think dig, the one that dig the core. Okay. So you need to make sure that it does not break. Okay. How do you measure that one? Oil analysis. So like you put sensors on oil. If the oil is if oil is bad, you have to replace as soon as possible. So that's why this is called precision. Okay. So you replace the oil whenever it is required. It depends. Maybe some part it is for harder, some part it is for uh, not harder, easier. Okay. And vibration analysis from the machine itself, you can know. Actually, you can feel also when you use your motorcycle. You can notice that if there is unknown vibrations, not unusual vibration, then you can see oh, there's something wrong with those. Okay, so this is something like this. Okay. So sensor data is collected, compared, and analyzed for deviation from the norm. So this is called anomaly detection. Okay, so you measure what is the normal, then you can identify if it is abnormal. Okay. So about 35 parameters are measured for oil analysis. Remember the parameters we put to indicate whether change of is required, as opposed to the every 500 kilometer method. Okay. So the type of metals in the oil indicate if a gearbox or bearing is failing. Okay. And the technology is set up from molecular values. So you have here anomaly detection, and then we have something called predictive analytics. Okay, you want to predict. So what it will do, if you predict that within 1 hour the system will fail, you shut down the machines. Okay. Then after that you change the oil, turn on again. It's safer rather than you the machine break down. Then you need to change many things, many parts. Okay, you need to change many parts. Maybe the downtime will be 1 day, not 1 hour, but 1 day. Okay. So and this is then the learn we this one used the principal component analysis, okay, PCA, to determine correlation between 10 to 20 variables, and then you have the K-mean clustering. I don't know the detail, but you can see here this is the machine learning algorithm used. And machine can use machine vibration, 16 vibration analysis sensor. Previously, what 35 for oil and 16 for vibration, which measure vibration on the z-axis. The data is made available at 10 kilohertz. What does it mean? It means that the data is sent every 1/10,000 second. Okay, 10 to the of minus 4 second. Okay, or every 100 milliseconds. 100 milliseconds, it ascends. Okay. So data analysis can and for which gear in the machine may be problematic. Okay, so this also has been used for predictive analytics or for jet engines. Still, this one learn machine data is valuables. This is machine data. As I mentioned, there are two nomics there. Okay, machine data and machine nomics, and then you have mining nomics, okay, to predict roof collapse. The roof collapse. Roof collapse, as you can see here, takes 7 to 10 days to clear the debris. Okay, and the cost of being offline is 15,000. Sorry, not per hour, per minute. Okay, 15,000 per minute. So you multiply this one. Yeah, 15 multiplied by 60 multiplied by 24 multiplied by 7 or 10 US dollars. Okay, 15K multiplied by this one. Okay. So based on many data points, including roof support, pump pressure, it can predict a roof collapse. So whenever there's roof collapse, then you need to do something. Maybe you put some another roof support to avoid the roof collapse. Okay, so long wall system needs about 8 people to operate, but it takes several hundred people to maintain the system. And the two, here you can see classic service contract, assisted service, or equipment as a service. Okay, so you can see here the improve the quality of service, reduce consumables, and so on. 50% utilization at the processing plants. You can also see here increase mine production by 55% and increase utilization by 20%. Okay, so you generated 100 millions in additional revenue. Okay. Okay, so I have 4 examples, but I will go to one more example. Okay, so you can read the rest. Farming is interesting. Just put the farming. What is interesting here is this one. You can read the details later on, but what is here is connect. Okay, you can see here. Or we have the fancy technologies, right? We have the Zigbee, Bluetooth, and we have other things. We can use LoRa, we can use satellite. But this one use only is called the term here sneaker networking. Okay. Use USB or SD card. What it means, you have the machines, log the data. Okay. Then at the end, because it does not need to be real time, okay, because the plant is not growing in real time. It's wait 1 day. So in 1 day, you do some things. Okay, you do some mapping, some growing, or you do some watering, you do some fertility, fertile soil or not. Okay, and then after at the end of the day, take the sticker, put it on the computers. This is also a form of collect. Sorry, no, not collect, connect. Can you connect from the? So that's why when you if it does not need to be real time, you can have something like this. Does not need to be as because as engineer, when you propose, the one is easier for you. Okay, but this is also can work. This also can work. Okay, you don't need to have fancy. You don't need to have satellite communication. So there's no coverage. The agriculture farm is very low, very large, very good. There's no fancy coverage. What you can do, put log in the logger data. Okay, log data, save in USB or data, analyze. Okay, so one more, let's see healthcare, precision healthcare. So this is the background. So every example here, I have the background, then we move on to things connect, collect, learn, and do. Okay, so we have the medical center of UC Medical use new technology to frequently monitor and transmit patient vital signals. What are the vital signals? Oxygen level, uh, blood pressure, yeah, right? And temperature, they measure or not, yeah, maybe body temperatures and heart rate. If you remember during COVID, we need automatic oxygen level. Right? So it's okay, but our lung is not taking up the oxygen. Okay, so what the normal they have the nurse. The nurse come to the patient every 3 to 4 hours. Okay, check this one. Okay. So what happens here if this is on critical condition? Remember that if you want to have more checking, you need to be put in the ICU, intensive care unit. Okay, but that one will be more expensive. We will check every 30 minutes, for example, check again all the things, temperature, blood pressure, heart rate, and oxygen level. Okay, but just but normally you don't need that one. You just need it when you need it. Okay, means that the person might not develop, or you might not be the nurse need not to check this one every 30 minutes, some things. Just let the machine do, still the monitoring, and alert the nurse whenever it is required. Okay, so this is called the code blue. Okay, in the medical term, this is called code blue. Okay, we have a really attention. Yeah, so the objective was to have software that alerted the nurses if a patient vital signs cross certain risk thresholds, so the patient will be immediately attended to. So now let's see the things. So use a Sensium or Vitals. Okay, Sensium Vitals is a wireless system designed to monitor vital signs in all areas of the hospital setting where patient would not normally be continuously monitored. This is means the normal ward, not the ICU. In the normal ward, the product is lightweight, wearable, wireless, single-use. This is important. Single-use patch. Single use. After you use for 3 to 5 days, throw it. Okay, so what's the concern? You need to be as cheap as possible. Okay, so that you don't need the fancy Raspberry Pi you put there. You don't need Raspberry Pi. Okay, or you put NVIDIA Jetson Nano, for example, you to monitor. No need. Okay, even the Arduino Nano will be still too expensive. Okay, so okay then the things this yeah in here they put heart rate, respiration rate, and temperatures with a high degree of accuracy. Okay, the page on the patient here. Okay, transmit data every 2 minutes. So you decide here 2 minutes. Maybe this is from the knowledge that the code blue will not happen within 2 minutes. Then it can detect. Okay? Not every minute. So not every 1 minute. If it requires, maybe they can change also. 1 minute, half minutes, and so on. Okay. So this is around 5,320 data points. We just multiply 3 by per patients per day, contrasted to every 4 to 8 hours for the current manual practice. Okay. So the page processing power is 8051. This is the old microcomputer. Okay, this is the old one. Okay. But this is have maybe yeah 16 megahertz. You can see here only 16 megahertz. Okay. Because the lower the frequency, then the battery, the lower the power that requires. Okay. And the page is disposable and has no operating system. Okay. So this is the things. Okay. So this is 1980s technology used in 2015. And the connect is again proprietary. Why you put proprietary here? Proprietary Zigbee-like protocol, not Zigbee, but Zigbee-like. Why is that? Because you don't want hacker to hack the system. It's a Python. If you are using the normal Zigbee protocols, then the hacker know all this protocol. I can hack. I can hack that all patients in this ward is have a heart attack. Okay, so the nurse will run to them, and the actual one will die. Okay, so it can be done if you are using the non-proprietary protocol. Okay. Proprietary is just to protect because there's no encryption. And also this is low power consumption and limit to 10 to 100 meters line of sight. Okay, so this is, for example, using Bluetooth low energy. So I can only point 10 to 100 meters maximum. Okay, so yeah, and this one has 250 kilobit per second. And what else? Yeah, disposable sensor for cost around 5 days, 50 US. Okay, so you can see here, $10 per day. Okay, $10 per day. Compared to if you pay the nurse to check every part, still more expensive compared to this. Okay. And also, what's the good thing here? The device can also be outside of network coverage. So what happened here? That's my so for up to 3 hours, and we'll store vital sign data on the patch. Okay. So a typical hospital requires 10 bridge, which connect the patch to the hospital. So what is put here? So you have the patient here, for example. Okay, you have the bridge, maybe put in here. Okay, this is the bridge. Okay, and then from here you connect to the server. Okay, and this is the patient. Okay, so you put the sensor vital here, sensor vital here, sensor vital. But maybe this one go to the toilet, for example. Okay, and this is outside coverage. So the vital sign can still be recorded here. Okay, but because it's not transmitted, so it will happen here. So the nurse will not know. Okay, what will happen. But it can have 3 hours outside coverage. So the moment he finished from the toilet, connected again to the bridge. Okay, so there's up to 3 hours saving, because otherwise, if it is important, then you can also install another bridge here. Another bridge. Okay, then you can connect to the server. Okay. Okay, so let's move on. So yeah. Okay, then the collect Hadoop is another one. Autonomous Hadoop environments running with, I think, a VMware instance is technical and on-premise Dell server. So the hospital buy Dell server and then get the VMware for virtual machines. Okay, and then you have the database in Hadoop. Okay, so Hadoop has two things here. This is designed for hardware failures. They're commonplace, so you need to be resistant to the failures. If it's past failure, still can work. It will not corrupt the data. Okay, so by design, Hadoop database is designed like. Okay, but you can see from here, 350 patients with reading every minute, create less than 100 gigabytes of data in 3 years, not in 1 month, not in 1 day, but in 3 years. So less data. Okay. So, and then you have also EMR or electronic health record. Okay, that they can put, I mean, you can put on the patient record database. You can include it in the patient database. So you do X-ray, your MRI, put it there. Okay, and then the vital signs, so put it there. Okay, so you have a complete analysis. Okay, after you are taking this drug, this is what happened to your vital signs. Okay, so the doctor can better. So remember, this is precision. Okay, so in our case, this is the learn. So you have the annotated code blue, the three vital signs. This one SPO2, PCO2, and MBP systolic. Okay, this is time series database, and then you can detect this is code. So this one means you have the classification. Okay, if you have code blue, or not. Okay, so you need to put emphasis on the code blue here. Okay, so only two class, code blue or not code blue. Okay, and just use the ARIMA models, auto regressive moving average, integrated moving average model in R, here in R at the time, and then also use support vector machine for classifier, code blue or not code blue. Okay. Then what is the do? An ability to precisely monitor patients. Yes, you can see here, this the word here, precisely. That's why the term precision, which have a significant health benefit. Okay, and then you can see here an ability to predict a code blue with reasonable accuracy within 90 seconds of the event. Okay, within 90 seconds of the event. So then you have you can save life within 90 seconds. You can put some treatments there. Okay. Okay, so that will be the healthcare. The rest, I think you can read yourself. Okay. And this is the Eclipse Foundation. Every year they put the IoT into consumer report. So this is what are the recent trends in the IoT. So just to close this one, uh, you don't need to memorize this one. Okay? You need to memorize this one. This is the report. What you can see. If you are given the problem, that you know how to what to report. Okay? So Java, C, C++, Java is the language for iOS gateway. Okay? And I think you have this one, MQTT protocols and CC forbid ARM architectures. For the IoT, you have your Amazon's 32%, Azure 22%, Google Cloud 70%. Okay, for the remember that when you collect, so this one is the combination of collect and learn and do. Collect, learn, and do. Uh, the, the things and connect is the IoT, and then you have the things and connect, and the collect, learn, and do in AWS, Azure, and Google Cloud. Okay, and you have concern around connectivity are on the rise this year. I'm not sure what happens. Maybe now they start to implement it. What? Maybe they start to implement the one that is outside coverage. Okay, so how to deal with that? Okay, so for example, you put like jungle monitoring. Okay, there's no connections. So how do you solve that one? Okay, then there's cloud fragmentations, and agriculture is the one that has emerged. After that, industrial automation, automotive, energy, and smart cities. Okay, and connectivity, as mentioned earlier, data collection, security. Okay. The important thing also on security, as you can see from here, that we don't remember that when you increase security, you need more power. Okay, you need more power. Okay, so now I think which one the IBM or Samsung has created the chip for encryptions. Okay, have the chip for encryption for IoT. Okay. And the other one is AI, container image, and Linux is still used. So if you have to go to the IoT, or whether you like it or not, still use it. Okay. Okay, the last one, just to recap, we have things, connect, collect, learn, and do. So make sure if you given the problems, the IoT people think like the IoT framework, so separate one by one. What are the things? The main thing is to this one. Okay, so this is the main thing. This also from IoT actually. This one already from IoT, but we have more here. How to make use of the data that generated, collect it, learn it, and do some improvement. Okay. So thank you. So I'll stop here. Any questions? Okay. I'll stop the recording. I have recorded.